The first problem I'd like to go over with you is number 6. Number 6, we are solving using any method. We have x squared plus 20x plus 96 equals 0. You could solve this one by factoring. You could solve it by completing the square. You could use the quadratic formula if you wanted to. But the easiest way to solve something that is a trinomial, x squared plus something with x plus a number, is to try factoring. So I'm going to try to factor. I need two numbers that multiply to give me 96 and add up to 20. And I know 96 is kind of a big number, so that's kind of annoying. But I know that 1 times 96 is 96, but that will not give me 20. 96 divided by 2 is 48. That's not going to give me 20. 96 divided by 3 is 32. That will not give me 20. 96 divided by 4 is 24. Could 4 and 24 get me 20? They could, but it'd have to be negative 4, and negative 4 times 24 would be negative 96, which we don't want, so that doesn't work. 5's not going to work. 6 times 16 is 96. That's not going to work. 8 times 12 is 96. Would 8 and 12 work? Yes. So 8 times 12 is 96. 8 plus 12 is 20. Our factored form is x plus 8, x plus 12. That's the factored form. To solve, if the first set of parentheses had to equal 0, what would x have to be? Negative 8, the opposite of whatever is in there. If the second set of parentheses had to equal 0, what number plus 12 would give us 0? Negative 12. So the first set of parentheses determines the first solution. The second set of parentheses determines the second solution. You should definitely circle number 7 and number 8. We are going to do number 7 together, but both 7 and 8 are very similar to questions on the test. If you have parentheses squared, you are going to get the parentheses squared by themselves and then square root both sides. So we are going to be solving by square roots. The first thing that we should do is subtract 4 on both sides. How could I get rid of that negative in front of the parentheses? Divide both sides by negative 1. So we would have the quantity x plus 5 squared equals negative 16. To undo a square, we square root. And when we put a square root in, we need to put a plus minus in front of it. Off to the side, let's think about how we could simplify the square root of negative 16. If you see a negative under the square root, that means there's definitely an I in there. There's a square root of negative 1, which is I. Then, what is the square root of positive 16? 4. So this thing is going to become 4i. So we have equals plus or minus 4i. Is this problem done? No. We definitely need to get rid of the plus 5. We will subtract 5. When we subtract 5 on the right side, you simply want to put it in front of the plus minus. So x equals negative 5 plus or minus 4i. The 4 is being multiplied by the I. It's attached to that I, so you cannot add the negative 5 and the 4. Okay, make sure you have number 8 circled. So far, you should have circled 6, 7, and 8. Those are very similar to 3 problems on the test. You should also circle numbers 9, 10, and 12. We are going to go over number 12 together. Number 12 is the square root of 7 over 27. You can split up radicals using division. So this is the square root of 7 over the square root of 27. The first thing that you should do is try to simplify all of the radicals that you see. So think about the square root of 7. Can we break 7 into a perfect square times something else? No, it's prime. So that one's good. How about the square root of 27? The square root of 27 we can split into the square root of 9 times the square root of 3. So this is, on the bottom, 3 times the square root of 3. We still have that square root of 7 on the top. Trying to color code all of this to make it make sense. Can I leave my answer as the square root of 7 over 3 times the square root of 3? No, we cannot have a radical on the bottom. So we're going to multiply the top and the bottom. We're going to multiply by a fancy version of 1, and we're going to use the square root of 3 over the square root of 3. Okay, on the top, 7 times the square root of 3 is the square root of 21. On the bottom, we have a 3. We also have a square root of 3 times square root of 3. The square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So we have another 3 on the bottom. So what is our final denominator going to be? 9. We have the square root of 21 over 9. You should circle number 13. There's definitely a question like number 13. And I'm just going to remind you quickly about operations with complex numbers. When you are subtracting, you have to subtract all of that complex number. You have to subtract the 2. You also have to subtract the 7i, the negative 7i. So we have 5 minus 3i. We need to subtract the 2. We also need to subtract the negative 7i. What is minus a negative 7i going to be? Plus a positive 7i. And then it's just combining like terms. You've got the 5 and the negative 2. Those would combine. The negative 3i and the positive 7i would combine. So your answer would be 3 plus 4i.
What about 4i plus 3? Is that the same thing?
4i plus 3 is technically, well, it's partially correct. The directions don't specifically say it, but you need to write your answers in standard form.
I thought it would be standard form with the I first. That's why.
Standard form is always the real first plus the imaginary part. It wants to put the real number piece first. So 3 is the real part, 4i is the imaginary part, so you need the 3 to be first and the 4i to be last. Okay, you should definitely circle number 17. I believe number 17 is a multiple choice question on the test. And then, if you're having fun circling things, every single multiple choice problem on the review is similar to a multiple choice question on the test. The reason I wrote that multiple choice section is so that you could get the practice on those types of questions. So numbers 18 through 27 on the review are definitely on the test, and they are definitely multiple choice questions. The few that I would like to talk to you about, I want to talk to you about number 19. Number 19 is supposed to be one of the easiest problems on the test, yet it is one of the most often missed problems. Solve x squared plus 3x equals 0. If you've got x squared and x, your best bet is factoring, but this is only two terms. How do you factor when it's only two terms? You need to think about greatest common factor. What do these two terms have in common? X. X squared, if we pulled one of those x's out, we'd be left with another x. 3x, if you pull the x out, you'd be left with 3. We are going to have two solutions. The first solution comes from the x. What number would you have to stick in place of x to make that yellow piece equal 0? It's kind of a trick question. Your first solution is 0. That's the answer that most people have trouble with. Your second solution comes from the parentheses. What number would x have to be to make the blue part equal 0? -3. If I put 0 in here, 0 in the yellow, 0 times anything would equal 0. If I put -3 in the parentheses, -3 plus 3 is 0. 0 times anything is 0. So you're looking for what would make that whole thing equal 0. 0 and -3. Number 20, make sure that you actually wrote down what the system is. Here's the system for number 20 in case you didn't write that down. And for this problem, you would do x squared plus 5x minus 25 equals 3x minus 1. Move everything to one side to get 0 on the other side, and then factor and solve. Number 21 and 22. Hopefully you remember about the parabolas. The negative in front in number 21 makes the parabola open down. The 1/4 smushes it and makes the whole U shape wider. Number 22, that plus 5 moves the graph. Number 22 is a little tricky though. It moves the graph up 5 from where it was at -1. So if it starts down 1 and moves the graph up 5, you're actually moving up 6. So I believe C is the correct answer for number 22. On the back, the biggest hint that I want to let you know is number 26. Next to number 26, you should write discriminant. The stuff that you see on the board right now, I will leave on the board for the test. With the discriminant, when you use b squared minus 4ac, if you get a positive number, that means 2 real solutions. If you get 0, that means 1 real solution. If you get a negative number, that means 2 imaginary solutions. And the object dropped or thrown formula, that h equals -16t squared plus v sub 0 t plus h sub 0, that will be on the board exactly as you see it. So you should have circled all of the multiple choice. And in the short answer section, the problems most similar to the test are 6 through 10, 12 through 13, and 17. In the song The 12 Days of Christmas, what happens on the first day of Christmas? The true love gives to me a partridge in a pear tree. You get 1 gift. On the second day of Christmas, what happens? You get 2 turtle doves and a partridge in a pear tree. On the third day of Christmas, you get, honestly, I don't care what the gift is, but you get 3 of something and 2 turtle doves